In today's practice lesson, we are going to continue reviewing some concepts that we'll be seeing in 6th grade math. Example 1 asks us to put the following fraction in simplest form. So I'm going to take this fraction and I'm going to rewrite it vertically. In looking at these two numbers, I can see that one of them ends in a 5 and one of them ends in a 0. Anytime you have a number that ends in either a 5 or a 0, it can be divided by 5. So I'm going to go ahead and divide both of these numbers by 5. I know 45 divided by 5 is 9. That's one of my facts. However, off the top of my head, I don't know 120 divided by 5. So what I'm going to do is I'm going to pull to the side and I'm going to divide it. When I go to divide this, 5 cannot go into 1, but it can go into 12 2 times. 5 times 2 is 10. I'm going to subtract that. 2 minus 0 is 2. There's a number to pull down, so I'm going to pull down the 0. 5 goes into 20 4 times, which is 20. So when I divide 120 by 5, I get 24. Now when I look at the 9 and the 24, I have to think if they have any common factors. One way you can do this is look at the smaller of the two numbers and think of its factors. So I'm going to look at 9 and think of how I can make 9 with multiplication. Well, I know that 3 times 3 is 9, so it can be divided by 3. I also know that 24 can be divided by 3, but let's say I didn't. One way you can see if a number can be divided by 3 is to take the digits in the number, 2 and 4, and add them together. When I do 2 plus 4, I get 6. This just gives me a smaller number to work with to see if it's divisible by 3. So I know 6 can be divided by 3. So when I get to this single digit, and if there were 2 digits in this answer, I would have to keep adding the digits together until I got a single digit. But if that single digit, or that number that I get there is divisible by 3, then so is the 24. Okay, so that means I can divide both of these by 3. And I would get 3/8. Looking at 3/8, 3 is only divisible by 1 and 3, and 3 cannot go into 8, so this is considered simplest form. Now this is just one way of doing this simplifying. When you simplify, you don't have to have the same process as your next door neighbor or as myself. You could have divided both of these by 15. 5 times 3 is 15. That would have gotten you down to simplest form right away. You could have started with 3 and then divided by 5. There's different ways of doing it. So if your simplifying is not the same as mine or somebody else's, as long as you wind up with the same simplest form, you're most likely doing it mathematically correctly. Okay, so now we're going to get into some word problems. Number 2 says, on the school field trip, there were 250 students, 10 teachers, and 8 parents. How many total people were on the trip? So here we're being asked to find a total number of people. In order to find a total in this case, we would be adding together the students, the teachers, and the parents. So I'm going to start by lining these up vertically, putting the longest number on the top. And then I just kind of put my smaller ones as I go down. Start in the ones. 8 plus 0 plus 0 is 8. 5 plus 1 is 6. And 2 plus nothing is 2. So there would be 268 people on the trip. Letter B says, if 5 parents each took 3 students home, how many people remained? So we know there were 268 people on the trip. So that's our total. If we want to see how many people remained or how many people were left, That's another word for remained, how many were left there. What I would want to do, so I'm trying to find how many remained. I would want to take away the number of students that actually went home or left. I know left and left are kind of confusing. These left, but these are how many are left at the field trip. So remained is the better word, I guess. So I have to figure out how many went home. So I have 5 parents. So 1, 2, 3, 4, 5 parents. Each one took 3. So this parent took 3, this parent took 3, this parent took 3, this parent took 3, and this parent took 3. So I could see how many altogether this made. I can do that by adding these 3's, 1, 2, 3, 4, 5 of them together. Or I can simply do 3 times 5 or 5 times 3 to get 15. Okay, so that means that 15 students left, but what it also means is that 5 parents left. Okay, so we've got a little tricky piece to that. So 3 students, but 5 parents. So I have to add 5 more people to the number of students that were taken. And that gives me 20 people who left. Okay, so I'm going to subtract that 20 here, and that's going to give me 248 people that remained on the school field trip. It helps to draw pictures like how over here I drew the 5 parents with the 3 each so that you can see. Number 3 says there were 200 pencils in the pencil container. After the first day of school, 85 remained. How many pencils were taken? So this is kind of similar to the previous problem with that last piece there. So we have 200 to start, or 200 total pencils. 85 remained at the end of the day. So if I take away those number that remained, I'll be left with how many were taken. So if I kind of do the opposite, if I'm taking away how many were remaining, what's left over will be how many were taken. Oops, I wrote the wrong word here. Taken. Okay? So when I go to subtract this, 0 minus 5 I can't do. I can't take from a 0. So when I have this situation, if I can't take from a 0, what I do is I underline the 0 and the digit before it until I get to a non-zero number. So 2 is a non-zero number. So in order to do this, I'm taking 1 from 20. So I cross off the 20 and make it a 19. And then I can make this a 10. Some people just jump over the 0, borrow 1 from here, make this a 10, then change it to a 9, and then get back. I just find this to be a little easier. 10 minus 5 is 5, 9 minus 8 is 1, and 1 minus nothing is 1. So there would have been 115 pencils taken. Make sure that when you're doing problems like these, you're really reading carefully.